Hello everyone, my name is Sumit Gaur from Impulse Technology. In this video, I will demonstrate to how to get dynamic conductance, that is AC and DC conductance of carbon chain attached to aluminum nanowire electrode using NanoDcal software. Let's start the video, and this is my device studio interface and my project name is ALCNAL. First I have to take aluminum atom, so go to the file option and click import local, then go to the 3D materials. Now click on conductor, then pure metal, and select aluminum atom. So you can see this is the aluminum atom. Now I have to make this atom into the molecule, so go to the build option and click redefine crystals and put the values. As you can see, I put it the value. This is -2, 2, then 2 also, then 4, then it will be -4, then 4, and then 2, 2, and -2. So then click preview option and then build. Now I have to delete some atom. So select the top layer atom and click delete. Then select this left atom also and click delete. Then go to the 3D option and click XY view. Then again select the left atoms and delete. As you can see, I this is the crystal. This is the molecular form of aluminum atom. What I need this project, and again I have to make this molecule into the crystal. So you can go to the convert to crystal option. Now put these values, some values, which will be the values will be 30, here 40, and then 30. Then click build, and as you can see there is a vacuum generated and tap center. Now next step will be to create a carbon chain. Take first carbon atom, so click file and then click new, then crystal. Values will be, you can see I have put it the values for previous lattice, that is A is equal to 30, B equal to 1.3 angstrom, C is equal to 30 angstrom as well. For angles alpha, beta, gamma are 90 degree, 90 degree, and 90 degree. Then I have to select my carbon atom, so click on plus, then put the values of fractional coordinate, that is 0.5 for P1, also for 0.5 will be P2, and as well as for P3 0.5. Then click preview option and click build. This is the carbon atom. Now I have to make this carbon atom into the chain molecule of carbon. So go to the build option, then click redefine crystal, and here you can put 5. Preview, then you can see this is the carbon chain and click build. As you can see, we will make the aluminum crystal and carbon chain also. Okay, then go to the build option, click device, and here you can see you can buy at your convenience whatever your device need. You can create using this left right structure, left center right structure, bottom top structure, bottom center top structure, forward backward structure, forward center backward structure. Here we will choose BCT, that is bottom center and top structure. So the next step, you need to select the atoms for bottom, center, and top electrode. Click. You can see your atoms, your molecule or crystal or something, whatever you create earlier. So I will select aluminum for bottom electrode. For top electrode, I will select aluminum also, and for center I will click carbon chain. So you can click match. Now click preview. Then you can see this is the device we made. Then put the values. I have something changed in this value, that is 1.2 for DTC. Also this will be 1.2. Then click preview and make build. Now I have to make the device crystal. So go to the convert to crystal option and click build. Then click center. Then remove the redundant atom upper and top. Now I have to make this device with two probes. I will need to two electrodes on top and bottom. So go to the build option, then click convert to device and click top and bottom electrodes and click preview, then build. So as you can see, my device are ready for the calculation. I will do all the calculation using NanoDcal. As you can know, NanoDcal can solve the all types of calculation in SCF form. So first I need to make the SCF input to make it. So I need to create SCF input for this device. To go to the simulator option, then click NanoDcal, then click SCF calculation. And this is my SCF calculations option. Then here you can see basic setting, contour integral, electrodes, iteration control, basic set, and spin type. Whatever you need, the parameters for this device, you can select here. Simply you can click generate. As you can see, files are generated for the this device. Here you can see three files are generated: device, bottom electrode, and top electrode. And every files have this SCF input. I will run the all calculation for top electrode, bottom electrode, and device electrode as well. So I simply click on SCF input for bottom electrode, click right and select run option and click run. For top electrode, I will also do it same, click run, and for device, click run. Since the calculation will be take the lot of time, I already done this calculation previously, so I will be shown all the calculations. As you can see, all the calculations are done for device, for bottom and top electrode as well. They're all log files are generated after the calculation. You can see the log file with open with, and you can see the all parameters are calculated here. And our main important thing for this device, we have to calculate the conductance. So simply go to the simulator option, go to the NanoDcal, click analysis and select the conductance. You can see the case sampling and number of energy points. You can change also and click generate file. You can see conductance dot input files generated. This file basically for the DC conductance. You can simply run it. Since this calculation also take a lot of time, I already calculated. But before the showing the result, I will show you how to calculate the AC conductance. For the AC conductance, this value. For the AC conductance, you have to copy this and go to the conductance dot input file and open with. You can simply change these all values for AC conductance and simply you can save it and cross. Then again you, after the running a DC conductance, you can run it and your two mat file for the AC and DC conductance are generated. This all calculation are be shown in MATLAB. I will show you. You can see all the calculations are done for DC and AC conductance. To show the result of conductance, we can go simply to the MATLAB and you can plot your all graphs and get your values as well on MATLAB. My file for names as DC and AC conductance, and you can easily locate your mat file for conductance output. So simply load your data, then type data, and you can see your all calculation are shown here. Simply type data dot conductance, then click enter. You can see this is the value of conductance, or if you wanted to plot this data, then simply type syntax plot data dot conductance. So you can see the graphs are available. If you're in DC conductance, generally we configure a different biasing voltage. So as you change your biasing voltage from the SCF input, your data result will be shown for different calculation, and simply you get that data and plot on the using the MATLAB. The next step will be for AC conductance. To get the AC conductance data, you simply locate your AC file and go to the device and get your AC conductance output mat file and load it. Simply load type data. You can see all the data are shown for conductance. You can see frequencies are shown here. If you want to frequency data, click your data dot. See, all the frequencies are available. If you wanted to copy this data for the plotting graph, you can simply click here data, and your all the datas are shown here. These are the data, that is conductance frequency. Click here, if you get your frequency data, and you can also copy this data and write on the Excel sheet or another type of graph analytical tools, and take the conductance output you get here. You can see you can also get this data by typing data dot conductance. See, also you can see this data here by using data dot conductance syntax. Now the if you wanted to plot the data on graph, so you can use the data with frequency versus conductance data and plot this data on. Also you can plot on MATLAB. Also you can plot Excel on another type of tools that used for plotting data. Like I already plotted this data on using the Excel. Here you can see I take this data on x-axis and y-axis and plot data, and my graph will be plotted.